Welcome back. We're still on the topic neurobiological theories and psychopharmacology, and we'll be continuing from where we stopped in the last lesson. In the previous lesson, we discussed key neurotransmitters like serotonin and dopamine, and how they affect mood, motivation, and behavior. We also looked at norepinephrine and how it acts as the brain's alarm system in stress and anxiety. Finally, we ended with a critical example showing how excess norepinephrine can keep a person in a constant fight or flight state. And by the end of this lesson, you will be able to 1. Identify additional neurotransmitters like GABA and glutamate and explain their functions. 2. Describe how neurotransmitters imbalances relate to clinical contributions and treatment approaches. Alright, so picking up from where we stopped in discussing some of the neurotransmitters and their imbalance, we will continue with the next neurotransmitter, the gamma-aminobutyric acid, also known as GABA. It is the brain's natural calming agent and it works to reduce activity and calm things down. Imbalance of GABA. Low levels of GABA can make the brain feel overstimulated, leading to anxiety and even seizures. Following the GABA is the glutamate. This is the excitatory neurotransmitter. Excess of it causes neurotoxicity, which is linked to Alzheimer's disease. Glutamate is the brain's main power switch. It is the most abundant and primary excitatory neurotransmitter in the brain. Think of it as the gas pedal that helps neurons fire. Moving forward, glutamate is essential for learning, memory, and cognitive function. Although glutamate is vital for brain functions, too much can lead to problem, which leads us to the imbalance of glutamate, and they include 1. Excessive levels can cause neurotoxicity, which means it can overstimulate and damage brain cells. This process has been linked to several neurodegenerative diseases, including Alzheimer's disease and Huntington's disease. Next, an imbalance in glutamate is also thought to play a role in mood disorders and schizophrenia. Many psychiatric medications work by balancing neurotransmitters. For example, antidepressants such as SSRIs increase serotonin levels. Let's look at another clinical example. In a patient with Alzheimer's disease, the nurse might notice problems with memory and confusion. A medication that works on the glutamate system, like memantine, may be prescribed. The nurse's role is to educate the family that this medication can help regulate glutamate activity to slow down the progression of symptoms, but it won't cure the disease. This is a critical teaching point to manage expectations and ensure adherence to the treatment plan. Finally, we are done with the neurotransmitters and their functions. Let's summarize what we have done in this lesson. 1. GABA acts as the brain's calming chemical, helping to reduce overstimulation, while low levels are linked to anxiety and seizures. 2. Glutamate is the brain's main excitatory neurotransmitter, important for learning and memory, but harmful in excess. 3. Imbalances in neurotransmitters can contribute to conditions like anxiety disorders, Alzheimer's disease, and schizophrenia. That is it for this session. Thanks for watching. See you in our next video.